Hey, welcome back. Today we are working on a 2014 Ford Fusion SE with a 1.5 liter EcoBoost. Customer complaint is check charging system light comes on up on the dash. This only started happening after they jump started another vehicle. She was at the grocery store, someone left their lights on, killed the battery, they had jump cables, they jump started it. She said they didn't jump start it backwards or anything weird, but now she's getting a check charging system light. So we gotta find out why. Maybe it was just a overcurrent type fault code, but normally that doesn't pop up every time. Maybe your check engine light would be on. But this one, when I pulled it up to the shop, it was not on initially, and by the time I pulled it up to the shop, it popped on. I just plugged in the Snap-on Zeus, identified the vehicle. Let's see what fault codes we have. And I'm just going to go ahead and do a full system scan because I don't know if all of the alternator data is going to be in the PCM. Some of these vehicles may have a smart battery module. Oops, I clicked on something I shouldn't have. But if the alternator is computer controlled, that's probably where we're going to find our codes. But we are just going to confirm that we don't have anything weird in any other module. While this is scanning, we can see in the bottom right of my scan tool, voltage at the data link connector is 11.9. What we're going to end up doing is checking voltage in the PCM. If the PCM is the controlling factor of the alternator, that will have all of our data PIDs. These Ford alternators on these newer vehicles, they have two communication lines, one to the generator, one back from the generator. They're not technically communication lines, it's just a pulse width modulated signal going to the generator. One varies up and down depending on where the PCM wants that alternator to charge. The other is just a feedback signal, the generator telling the PCM, yeah, we got your signal, here's how much we're charging. So we have two codes in the engine, same codes in the transmission, same module. P0625-00, generator field F terminal, circuit low, that's a pending. And then generator control circuit range or performance, not current. So one may have happened right away and the other one is a pending, just even on this key cycle, and we haven't even started it. We'll scroll down here, we have some headlight codes, battery voltage above and below threshold, and anti-lock brake module. Oops. And power steering has a battery voltage code as well. Now these are all non-current except for the one pending code for generator field terminal circuit low. We'll go back out of here. Go to engine. Let's go ahead and start the car up and see what our charging voltage is. So far at the data link connector, we're just sitting at 12 volts. It hasn't updated. There we go, 14.6. So we are charging. The alternator is functional, but we're still setting that code. And it might be a good idea at this point, to clear those codes, see if they come back, because maybe the fault code just set whenever they were putting that heavy load on it, and it's possible now that there isn't an issue. Okay, I just got a warning light. I do have the hood popped. Check charging system came up on the dash. We have hood ajar. Let's see the battery light and check charging system. So let's check our data PIDs. We have relay switches, charging, and AC data. If I can push the button. There we go. May not support all PIDs. That pops up on every Ford. We'll wait until everything pops up here and see what we have. Okay, I'm going to actually narrow this list down because we don't need all the extra stuff. We just want to look at the good stuff related to battery charging. On the newer cars with the custom data list, it gives us possibilities of pulling data PIDs from each one of those categories. So this takes a little bit to load all of the PIDs from all those different categories, even though we're only going to be pulling from that one category. So I want battery voltage. Generator command, generator current, voltage, generator, 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 module voltage, reference voltage. I don't think we'll need those, but just in case. And let's check out that stuff. We'll go to a graph view. It's not too much stuff, but if you go to the custom list, you can put more stuff in a graph than if you just graph stuff manually. So looking at this, down at the bottom, our battery positive voltage and our module supply voltage, they're reading about the same, which is 14.5 volts. The alternator is charging. Our generator current sensor is showing that we are currently pumping out 50 amps. Let me kill the headlights. And it's bright outside, so they may not have been running anyways since I'm in park. We turn off the heater control and the rear defroster. I don't see heated seats anywhere. With that stuff turned off, my generator current sensor is dropping down, so that seems to be functioning. I don't know if this has a remote sensor. It probably does, either around the battery cable or on the positive or negative battery post. So right away I see that our generator monitor percentage is at 0. I'm not exactly sure where it's supposed to be, but that may be the issue, is our feedback. Even though it said the code was for the field circuit, maybe our feedback is not sending a duty cycle back to the PCM. Generator monitor frequency is at 0 hertz, but our command is at 63.57. Now, I didn't see that command change at all with those loads on. So we may just have an issue where that alternator, whether it's because of the heavy load from the jump starting or for no other good reason, has failed, and perhaps that regulator is no longer capable of sending back a signal for the feedback. I think next step is we are going to have to verify the signals going in and out of the alternator. So we have generator monitor and generator command. A lot of times in the data PIDs, they'll be called gen mon and gen com, and same with the wiring diagrams, depending on which diagrams you're looking at, which scan tool you're using. So I'm going to go back to the home screen. We're going to go to guided component test, and this should give us a pinout. If it doesn't, then we will have to go pull up a wiring diagram. See what engine we have here. 1.5 liter EcoBoost. Charging system. Component information for the alternator. So it is a 3-wire connector on the alternator, and I did pop the hood just to look at the battery, look at the alternator, make sure there wasn't something physically wrong. Everything looked fine, and I can get to this alternator connector fairly easy to do this testing. So we're going to have, it says pin assignment, pin 1 is generator load input, gen 2 is regulator control, and 3 is fuse 46. So is it possible that they popped a fuse and that's why we're not getting a signal back? It doesn't show us a wiring diagram of where those things go, but if we might have to just read a little bit on the left side of the screen. 2 communication lines between PCM and the generator. Gen com, gen mon. So even though it gives us that information in the component test meter, there isn't actually anything in here for testing the monitor or the command signal. I'm actually going to go back and just check in engine to see if there is something for the generator. I see the current sensor, but I don't see anything for the actual alternator or generator. And this is one that you're probably going to want to use an OEM alternator because of how picky these systems are. The aftermarkets don't always have the exact regulator in there, and it may not make the PCM happy. Okay, we're going to jump into wiring diagrams. This thing did load for us. We will go to charging system or starting and charging. So our alternator has 4 connections. Our big power lead, which is the big red number 1. And then we have 3 other ones, 1, 2, and 3. Violet, blue, and orange, and brown and red. Let's see where those go. So our violet is going to be gen mon. Our blue and orange is going to be gen com. And brown and red is going to go to 10 amp fuse number 46. So while we have the scope out, we can just verify if we have power on that third wire. Okay, so there is our alternator. Go back to our diagnostic suite here. We're going to go to our home page. Guided component test didn't help us on this one, so we're going to scope multimeter, change our settings. We want 2 channels. We don't need 400 volts. We'll start with 20 if they're battery voltage signals or if they are a 5-volt signal. Turn off my cursors. So I think the first thing I'll do is check our green with a red, which is our top pin. And we can see on the screen that we have battery voltage. If I minimize that and pull this up, our live voltage is 14.5 volts. So that tells us our fuse 46 is good. Not to look back at my wiring diagram at which wire was which here, because my memory's terrible. But I'm just going to go ahead and plug in both of my test leads to the other 2 remaining wires. So those are probed in. We wiggle the yellow lead around because it's showing ground. So is it indeed shorted to ground, or is the regulator just stuck to ground? So I think I'm going to unplug this and then look at the scope and see where we're at. Okay, there we go. So by unplugging that alternator, we confirmed 2 things. Our wire from the connector to the PCM is not shorted to ground, and the PCM is the one supplying the pull-up voltage. So PCM supplying 12 volts, and the alternator is supposed to pull that to ground and toggle it to ground, but the alternator is just stuck to ground. So more than likely the transistor in the regulator, whatever is commanding that, is bad, and it's just stuck to ground. Our other wire, with that connector unplugged, we're only bouncing between 0 and 3.8 volts, but I believe when we were plugged in, we were bouncing around full 12 volts. We plug that back in. Yeah, so we are running, full battery voltage. So what it is the alternator is supplying our battery voltage on that wire, and the PCM is the one that is pulsing it to ground to control our alternator. We don't even need to do that. I was going to check for battery voltage at the alternator B+ terminal. We don't have that an issue there because we can reference the battery, and the battery is charging at full voltage. And I guess we'll check it just to make sure, but I don't foresee there being an issue or a voltage drop problem between B+ at the battery and B+ at the alternator. But what we can do is we can just grab our 2 test leads. I will touch one of the test leads to the alternator B+, the other one to our battery B+, and we'll make sure that they have the same voltage on the screen. They do. If we look at our screen, live voltage is 14.58 on one and 14.54 on the other. So we have a few tenths of a volt or hundredths of a volt difference between the alternator and the battery. And if this thing is still putting out 20 or 30 amps, then that voltage drop is minimal. So I'm going to call an alternator on this one. I don't know how far out a factory alternator is going to be, or if the customer will approve it, but hopefully they'll get this taken care of. We probably want to test that battery, make sure that it is actually still good. It is from 2018. It's an interstate. It's looking kind of funky. So either way, we need to clean it up. But before we send it out with the new alternator, we'll make sure that that battery is fully charged and tests good. Okay, so the customer with the Ford Fusion, I noticed that it was about a half gallon low on coolant. And they said that they have added coolant a couple times. There was no external leaks, which more than likely means that it has a bed head gasket. Those are ones that there is a service bulletin for a new design short block. They have issues with them. They decided they didn't want to put the money into it. They're just going to go trade it in at the Ford dealership for a new vehicle. So we didn't get to fix the alternator on that one. But next day, I have a 2011 Ford Mustang with the check charging system light on. So we're already kind of versed in, how the system works off of that last vehicle. I just hooked up the scanner. I think it just completed the code scan. So let's go ahead and, pull that up and see what's going on. The customer also said sometimes his dash gauges will go out or go kind of wonky. So maybe the code scan will have something in the instrument cluster as well. So looking at this code scan, we have P0563, system voltage too high. This is a non-current DTC, and that's a pretty good indication of why the dash would go dead. If the voltage got too high, it could freak stuff out. And we also have a P0625, generator field F terminal circuit low. That's the same code we had on the Ford Fusion, and the regulator inside the alternator was bad. It was pulling that wire to ground instead of toggling it like it was supposed to. So I think we're going to end up doing the same testing on this one. Let's go ahead and scroll down, check instrument cluster just to see. Look at this, analog brake, power supply above threshold. So we have quite a few modules that were experiencing over voltage. Communication issues, voltage above threshold. Pretty much everything is communication or voltage too high. Okay, so let's go ahead and do the same thing we did with the last one. We'll jump in here to engine data. We're going to go to charging system data. We'll do the custom data list just like we did on the last one, even though it takes a few seconds to load. Okay, from that last one, we noticed that the generator monitor signal was always stuck at 0. Now, I didn't actually read in service information where that was supposed to be, what frequency it was supposed to be, but more than likely it's not supposed to be a frequency of 0, because that would be outside the realm of a normal signal, and that would be in the fault criteria for short to ground. So we have module voltage. Hopefully we're not too low to start up the vehicle. Desired voltage, communication, or the command duty cycle, our monitor percentage, monitor hertz, and we have command line and fault status okay. Let's see what happens after we fire it up. The monitor line immediately sets a fault low. Command duty cycle is 60%. It is charging properly at this time, but the monitor frequency is 0, percentage is at 0, and we'll see if the fault indicator lamp comes on. There it goes. We just got a warning ding, and it switched over to generator fault indicator lamp on. Holding the RPM up doesn't cause the voltage to spike, but if there's issues inside that regulator, it could easily spike at random. So let's go ahead and shut this off. We'll hook up the scope leads just like we did on the Ford Fusion. We will check the gen mon and the gen com signals at the alternator, and we'll unplug the alternator just like we did on the last one and see if that monitor line lifts back to 12 volts. And that will verify that the short to ground is internal of the regulator and not somewhere in the wiring harness. Okay, our scope is still set up from the last vehicle. So we have a duty cycle on one wire, 0 to 14 volts. I did not pull the wiring diagram on this one, but I don't see a duty cycle on the other wire. So let me unplug this connector just like we did last time. The other one unplugged easier than this one, of course. And that other wire does go up to 12 volts. So our pull-up resistor inside the PCM is good. We can still see that slight duty cycle on the other wire, even though we're disconnected. We don't have that 12 volt pull-up from the generator on our green trace. Plug this back in. That other wire goes back to 0. So that's it for the diag on this one. We know the alternator B+ terminal is good because we are charging. We just have another faulty regulator. Now, this customer didn't mention anything about jump starting it or jump starting anybody else like the last one. So maybe it's just something with these regulators that they are very sensitive and can fail easily. What we will do, even though it has a new battery, we'll double check that battery and make sure it's good. But this is another one. I'm probably going to get an alternator from the dealer because I don't feel like, you know, chasing regulator issues with an aftermarket regulator, not knowing if I misdiagnosed the vehicle or if the regulator is just faulty. So we'll see if this customer will authorize the alternator. We'll get that installed and we'll retest it, and hopefully we'll get a known good capture to throw in our waveform library. So the customer on the Mustang declined the alternator, and then they called back 3 days later and authorized it. So we got the factory Ford alternator, showed up, I installed it. Very easy alternator to do on this, just 2 mounting bolts, the power cable, release the tension off the belt, and then that 3-wire connector just unplugs and the alternator just comes right out. It's very accessible. Now, this vehicle does have an aftermarket intake, so I'm not sure if the factory setup is as easy as it was on this one, but I have a feeling that it probably would be. So what we're going to do is we're going to just, turn the ignition on. We are going to pull codes, clear codes, and then we'll fire the vehicle up and verify that everything is working properly. We'll scope those 2 wires at the alternator, and we'll check and see what our battery voltage is, and then confirm that we don't set any new codes. And we'll probably start it up a couple of times just to make sure that there are no issues. Sometimes these things will take a couple of key cycles to set the codes. I know this one was setting it right away, and that check charging system message would come up on the dash, but we'll start it a few times just to verify. So we're going to go back with a 4-channel lab scope. We're going to turn on 2 channels, put some more time on the screen here, just so we can look at our waveform. And even before we get started, I see some sort of activity there. Change these both to 20 volts. And that's probably the PCM testing to see if the alternator is there, to see if it's going to set that generator fault code. I'll go ahead and fire it up and see what kind of signal we get. Because before we only had a signal on one wire, and the generator was actually shorting the other wire. So we may just have to let this run for a little bit and verify that the command does drop down after the voltage of the battery, comes back up. Well, we just saw a little blip there. So I got a feeling that it's starting to realize that that battery is fully charged, and we're going to see some changes here shortly. So there we go. I just saw a little blip. Let's zoom out. So there we go. We are not shorted to ground on either one of the wires. We are getting communication back and forth, even though it's a rudimentary, just a duty cycle command and a duty cycle confirmation back to the PCM of what's happening. we are getting activity. So neither one of those are shorted to ground. Our codes did not reset. Let me go ahead and shut the vehicle off. I'll start it back up, make sure that it's not going to set on the second key cycle, and we'll refault codes again. If everything's good, then we will call this one done and ship it out the door. Okay, so I fired it up again. I did turn the key off for about 10 seconds to let that PCM shut down. That way we can guarantee that we're getting a second key cycle logged. Every once in a while I do get a pulse on the yellow wire, which is our command. So I'm guessing that 0% duty cycle is requesting full charging. And as it starts to oscillate and give a lower duty cycle, we would have or a higher duty cycle, however it's measured on this one. 0 might be 100%. Pulling it to ground could be 100% duty cycle, or it could be 0% duty cycle, depending on if it's looking for the on time or the off time. So let's go ahead and go back out of here. We're going to look and make sure we haven't set any codes, and we probably need to clear all the codes in the other module, because if you remember last time we did a full system scan, it had over voltage codes in all the modules. And what I'll do is I'll unhook the scope, and then I'll probably just go drive it just to verify that the voltage doesn't exceed 15 volts while driving. No pending code and no memory codes. Clear all the codes out. I'll go drive it, make sure everything's good. If you guys have any questions or comments on how these systems work, I think we covered it good enough. We have a generator monitor signal. We have a generator command signal. Those are two lines that go back and forth from the PCM to the alternator. The PCM supplies a 12 volt pull-up voltage on the monitor signal, and the alternator toggles that monitor to ground. Basically, it's Morse code. The alternator is just tapping that to ground to tell the PCM information. Now on the command signal, the alternator supplies 12 volts, and the PCM pulls that to ground to tell the alternator that we want either more charging or less charging. The third wire on that connector is just I believe an ignition feed key on power, and we have our big battery terminal, which is constant power. We verified that we had full battery voltage at that big terminal at the beginning, and on our key on terminal we found out that our monitor signal was actually shorted to ground by the alternator. It wasn't giving any type of duty cycle, it was just pulled to ground, and that code would set immediately for our, I believe is our field control circuit low. So at least on this engine and on that Ford Fusion we checked at the beginning of this video, the alternator was easy to access, easy for us to hook our lab scope up and confirm. We unplugged the alternator to verify that the wiring wasn't shorted, and our monitor line went up to battery voltage, which told us that the wire is not shorted and the short was actually in the regulator on both vehicles. So it must be a common failure or fault mode of that regulator to short that wire to ground. Questions or comments, put those down below. Thanks for watching. I'll see you next time.